Welcome back. Today we're going to be talking about the Wheatstone Bridge. So let's suppose we have a problem here. So for the circuit below, we have to find our U, which is our unknown, so the unknown resistance, given R1, R2, and R3. So our circuit is fairly straightforward. We have the Wheatstone Bridge, which is done like so, putting those resistances, and we have a voltage supply here, voltage source, and nothing in between, and in a meter here, just like that. So R1 is going to be here, R2 is here, this is our unknown, which is the one we have to find, and it's going to be R3. So basically what we have to do is to find R unknown. So we have three resistances for which we know the values, and one for which we don't know the values. So the value for R1 is 2 ohm. The value for R2 is 4 ohm. And the value for R3 is 3 ohm. We now have to find Ru, so R unknown. Now, to do that, we can do a few things. So first of all, what I'm going to do is to use the Kirchhoff current law. Now, the Kirchhoff current law, so KCL, basically means that we know that the current entering a node at any junction is equal to the current leaving that junction. So if I'm gonna write it, it says that let me just write it. So Kirchhoff current law says that the current entering the node at any junction is equal to the current leaving that junction. What basically means in this case is that each one of those resistances are going to have a current. So if I put the current here, let me just use. So R1 is going to have a current called I1. R2 is going to have a current called I2. R3 is going to have a current called I3. And of course, Ru is still going to have a current called IU, so I unknown. Now, to get that, basically, the fact that the current entering a node at any junction is equal to the current leaving that junction basically means that we can easily write I1 in terms of I2 and I3 in terms of IU. So it basically says that I1 is equal to I2 and that I3 is equal to IU. Now, what this is important because it's gonna allow us to go farther. To go farther and proceed, we're gonna need also the Kirchhoff voltage law. So the Kirchhoff second law. This is the Kirchhoff first law. So the Kirchhoff voltage law, Kirchhoff voltage law, basically says that the sum of all the voltages around the loop is 0. So let me just write it. So the sum of all the voltages around a loop is 0. Therefore, in our case, we know that V2, so basically each one of those is going to have a voltage as well. So V2, V1, V2, V3, and VU, so V unknown. So in this case, we know that V2 over V1 is going to be equal to VU over V3. So we can write it. So V2 over V1 is equal to VU over V3. But we already know that, first of all, we now have this expression in terms of voltages, and we also know the equivalence in terms of the current. Now we can just use Ohm's law to get the resistance, because we are actually interested in the resistance, and we can express V in terms of I and R. If you don't remember the Ohm's law, it's fairly easy, because you just have to remember this, and you basically cover, as I said many other times in the lecture, you want to find V, you cover V, and it's given by I times R. So we know that V is equal to I times R. So if we substitute I times R in this expression, what we get is that instead of having V2 over V1, we have I2 over I1 times R2 over R1. So R2 over R1. And here as well, we have, instead of VU, we have IU over I3. So we have IU over I3 times, RU over R3. So RU over R3. Now we're getting closer. How do we get rid of those? Well, from the Kirchhoff current law, so basically from the first law, we already know that I1 is equal to I2 and I3 is equal to IU. So basically we have the very same value divided by itself. So this one is just 1 and this one is just 1. So we can easily simplify them. So this one becomes 1 and this one becomes 1. So what we have right now is 1 times R2 over R1 equal to 1 times RU over R3. So what this means is that, well, when we just multiply by 1, we get R2 over R1 equal to RU over R3. And now it's just easy because we want to find RU. So we can easily just multiply by R3 on the left and on the right. So if we do that, we get R3 times R2 over R1. So R2 over R1 equal to RU over R3 times R3. So those two cancel out, and we are left with R3 times R2, everything over R1, which is equal to RU. So we now have a direct relationship within RU, which is the resistance that we didn't know anything about, and the other resistances, so R1, R2, and R3, for which we know the values. So we just have to plug the values into the formula that we have just found, and we are going to solve the exercise. So we know that, as I said, Ru is equal to R3 times R2 over R1. So R3 times R2 over R1. Now Ru, so our unknown, which is soon going to be known, is R3, so 3 ohm. So 3 times R2, which is 4 ohm, everything over R1, which is 2 ohm. So Ru, 4 times 3 is 12 over 2. We get that Ru is 6. So we now know the value of Ru. So as you can see, it's not something impossible. It's doable. It's actually pretty straightforward. You just have to use the basics. You don't need things like, I don't know, Millman or other thing. I mean, you just apply the very basics. So you don't need anything advanced to find the value for a resistance in a Wheatstone Bridge, because you are just going to use the Kirchhoff first law, so the KCL, Kirchhoff second law, KVL, and then Ohm's law. So, I mean, it's fairly easy. But why did you do that? Because, this is something I didn't cover. I realized I didn't cover in the very first in the very first lectures, and before ending the course, I really wanted to, uh, at least talk about it. So yeah, this is basically the basics that you need to know about Wheatstone bridges. So as always, I hope it helps. Cheers and goodbye.